Alrighty, so let's go ahead and get started building the app. In this video, what we're going to do is we're going to put together a couple base classes and some authentication stuff and two activities. I'm basically creating a small little skeleton of the application just to get some classes that we're going to need out of the way kind of in one video and to set us up for our next discussion, which will be about how to deal with our login screen, our registration screen, and our main activity. So just again, because there's going to be a lot of like catch-22s, like you need this class to do that class and that class to do this class, I wanted to get just like I said, the basic skeleton out of the way first, and also go ahead and just create the project itself, get the project template going. So I'm looking at the welcome screen for Android Studio. I'm going to go ahead and say start a new Android Studio project. And for the application name, I'm going to go ahead and call this Youra, Y-O-U-R-A. And I'm going to go ahead and leave the project location where it is, and I'm going to keep the company domain as buzz.com. Obviously, you'll want to change that to whatever you want to use, something that would be unique. Now I'm going to go ahead and hit next. For our target SDK, I am going to go ahead and select Android 4.2 Jelly Bean and make sure that only phone and tablet is selected. We're not worrying about the TV or Wear glass. And then for our add an activity to mobile, what I'm going to do is I'm just going to select add no activity. I'm not going to worry about adding a blank activity because I don't want to worry about the menu classes or anything like that. In fact, we're mostly going to be writing our activities manually from here on out in the video series so that we don't have to deal with all the other stuff that auto generates for us, like the menus, which we don't need all the time, and also deal with the fact that we have our own base classes, and also deal with the fact that we're going to be kind of overriding our own onCreate method. So it'll turn out to be actually faster for us to write our activities from scratch. The only caveat, of course, is that we'll have to make sure to add that activity into our manifest. But with the power of autocomplete, we can do that pretty quickly. So select add no activity and hit finish. All right, so go ahead and give it some time to Gradle. So the first thing that we're going to be doing with this project is creating what's called an application class. No, I don't know why that popped up all the way there. An application class is it's a singleton object that's instantiated for your application, and only, like, because it's a singleton object, only one of those objects exists. It's an excellent place, basically, to put objects that you want around for the lifetime of your application so that you can cache information. So what kind of stuff would you need to cache? Well, for example, you definitely want to be able to keep track of a user that's logged in. Because this application is basically kind of like this social networky type thing with friends and messages and all that fun stuff, you need to know which user logged into your app in order to display things like what your name is and so on, as well as to enforce whatever authentication protocol that we'll end up using. In this case, it's going to be OAuth 2. If you don't know what OAuth 2 is, don't worry, we'll explain it when we get there. So the application object is a great place to put that sort of information. Now, if you're at all familiar with design patterns, such as the singleton design pattern, you'll be asking, well, so you have this object that's going to live for the duration of our application. It'll stay alive between activities and so on and so on. Why not just use the singleton pattern? Why not just use static fields? It really just comes down to a matter of style. I prefer that... I highly discourage the use or accessing static members in general, because that'll typically reduce the testability and flexibility of your code. Just on principle, that doesn't mean I don't use static objects myself, but I try to avoid them. And B, I really like having a sort of central location for all of the things that are expected to be alive, all the objects that are expected to be alive during our process, so that they are initialized in the correct order and they're configured properly, and there's only one place to look to see where they are. So we're only going to have a handful of things, only a couple things that we're going to be stuffing in our application object, but that is where I would put any sort of object that needs to be alive during the duration of your task, of your entire process, that needs to be shared between activities. So yeah, let's go ahead and implement that. So basically, the way that you get an application object is the application object already exists. But what we can do is we can subclass it, and then we can tell Android to use our subclass rather than the default application implementation. Then every activity and fragment and service and all that fun stuff is going to get a reference to that application object. So what we can do is we can then cast the base application object into our custom application object. All right, so I'm going to go ahead and open up my project window. Let's go ahead and get started. The first thing I'm going to do is I am going to go ahead and create my application object. And I'm also going to create, or application class rather, and I'm also going to create the first global class that we will be putting in our application. In fact, I kind of want to do that first, just so I don't have to switch around between code files so often. So I'm going to start off with a DTO. I'm going to start off at, basically we're going to make a DTO for our user. We're going to make an auth class that holds our user object. So our auth class is responsible for holding that user object and understanding our auth tokens and all that stuff. And then we'll have our application class, which will own a reference to our auth class. So that's kind of the hierarchy that we're working with. So what I'm going to do is I am going to go ahead and we're not going to be using the default package or the base package here. What we're going to be doing is we're going to be putting our application class, our auth class, and our user class into a sort of infrastructure package. Which I typically use for miscellaneous sort of things, such as the application class. So what I'm going to do is I'm going to make a new package. I'm going to go ahead and right-click on Combuzz Eura. I'm going to go up to New, and I'm going to select Package, and I'm going to call this Infrastructure. Yeah. And then go ahead and hit OK. So now we have Combuzz Eura, and then underneath that we have our infrastructure package. So now what I can do is I can right-click Infrastructure and select New and create a new class. This class is going to be called User. And the user class is basically going to be responsible for containing all of the information about the currently logged in user. So, for example, if you had if this was Facebook app, this would be your profile, your account. It would contain things like your username, your display name, your avatar, and so on. So I'm going to go ahead and clear this comment out. And what I'm going to do is the way that I'm going to implement this class is it's going to be a DTO. And what I mean by DTO is it's going to be simply responsible for containing data. Data stands for data transfer object. To call a class of DTOs to describe the class as only containing data but no actual behavior. So in this class, what I'm going to do is I'm just going to create some fields. Then I'm going to use IntelliJ or Android Studio to auto-generate getters and setters. If you're coming from C# or other languages that support properties, you might be surprised to hear that Java does not support property syntax, meaning that in order to have proper encapsulation where your fields are private and your accessors are public, every field is going to correspond to two methods. Let me go ahead and just write out the first one without using the refactoring to show you guys what I mean. So let's say that I want a private string int ID. So I have a private int ID. This is our private field. One of the pieces of data one of the pieces of information that I really want to have available globally within our application. The ID of the user is logged in, and we're going to use integers for that. Okay, so basically this is going to be a private field, so I need a public way to access it. I need a public way to get it, and I need a public way to set it. And the reason we need that is when we do actually successfully log in, we need to tell this user object that it has logged in and what its ID is. So that means I need two functions, two methods. So I'm going to say public int get ID and simply going to say return ID. Then I'm going to have public void, set ID, ID, and then I'm going to say this.id equals ID. So basically, for every single piece of data that we need, we are going to need one field and two methods. One method to get the field, one method to set the field. Also notice that I have to specify the this.id equals ID because we have a naming conflict inside of this method. Namely, our ID parameter conflicts with the name of our ID field. So in order to reference the ID field, I have to qualify it with this. If I were to remove that, notice how IntelliJ is warning me that I'm setting ID to itself, and that I have to fix this by setting this.id equals ID. Now, the Java standard naming conventions are that fields are lowercase and are not prefixed. In fact, that's the naming convention for a lot of languages, including C#. I just happen to not follow it with C# because I don't like that at all. I prefer having our underscores, meaning I prefer fields to be prefixed with an underscore so that the code would become that, reducing the need of using this and making it immediately clear as to what is a field and what isn't. However, since the Java convention is to not prefix, I will go ahead and follow that and not prefix all my fields, resulting in a redundant this qualifier on some of our properties, or on all of our setters. Anyway, so that's the slow way to do it. There's a slightly faster way to do it. So let's go ahead and do a print, private string, capital S, remember that. I almost inserted an underscore there. Username. So for username, I am going to go ahead and make the N capital on username. So it'll be user capital N-A-M-E. And I'm going to really try to enforce that particular spelling or that particular casing throughout the entirety of this application. But anyway, so I went ahead and I wrote out this private field. Now let's go ahead and use our tool to generate our getter and setter. We can do that by hitting Alt-Enter and then adding set create getter and setter for username. Hit enter. Now we have our get username and set username methods appearing down here at the bottom, and they appear to be correct. Very similar to our ID, our get ID and our set ID. So next, let's go ahead and do our display name. So private string display name, and then I'll hit Alt-Enter and I'll say create getter and setter. Now we have these two methods down here, get display name and set display name. So let's go ahead and just go through the rest of them. We need our avatar URL. So I'll go ahead and create a getter and setter for that. And we're also going to need our boolean is logged in to determine if we have logged in or not. And then a private boolean has password. I really want to put that underscore in there. And then a private string email. Okay, so these are just the fields of our user type. So we have our user DTO, basically. Our ID, our username, our display name, our avatar URL, is logged in, has password, and email. Now our ID and our username and our email and our is logged in should be pretty straightforward. Our display name is going to be, basically when you log in and you register for this application, I'm going to make the username constant. So meaning once you choose your username, you won't be able to, or once you choose your username, you won't be able to change it to anything else. However, I do want the just for demonstration purposes, I guess, I do want the ability for people to be able to change how they appear to other people, what name pops up. And so that's why I differentiate between the username and the display name. So you could use the username for things like URLs and logging into the application and so on, and then the display name for how you appear to other people. The avatar URL is simply the URL for the user's avatar. That's pretty much all it is. Is logged in, of course, as if we're logged in yet. Has password. Now, the way that we're going to be able to log into this app, we're going to be able to log in using OAuth. And we're going to be able to log in using accounts that are created specifically for this application through a register screen or through Facebook or Twitter. So a user will be able to sign in through Facebook, get into our app, choose a couple pieces of information, then hit create the account. Then they'll be able to log in through Facebook if they want to. However, sometimes they won't have a password. If they did that, they won't have an actual account that has a password for the service. So we need to keep track of if they have a password or not, because down the road on the profile page, they can change their password. And we need to be able to say, do you want to create a password? if they don't have a password, or if they do have a password, we want to ask them, change your password. So we need to keep track of that. And then the email is just our email. So that's our user class. Let's go ahead and jump into our auth class. So I'm going to right click on Combuzz URL infrastructure. Also note a frustrating thing. Notice how IntelliJ or Android Studio decided to eat our package. What do I mean by that? Well, you see how it's collapsed now? So Combuzz URL infrastructure. So it's going to be a slightly a bit of a pain to create another package in the future. But I just wanted to point out that IntelliJ will collapse packages into the least amount of folders possible. Anyway, we'll go ahead and right-click that, go to New Class, and then we're going to create our auth class. Now, we'll be coming back into our auth class once we start adding things like our auth tokens and all that fun stuff. But for now, what we're going to do is I'm going to say private user. Then I'm going to go ahead and generate a constructor. Or I'll go ahead and do, I'll show you guys a magic trick. So I'm going to say private final context. Now, what's a context? In Android, a context is one of the sort of God objects, I guess. In fact, activity, remember how I referred to an activity as a God object earlier, is a context. You can think of a context just as, well, it's a context for all the things that can happen inside of the application. So it's like a little island, like an activity is a little island of functionality. That is what a context essentially is. A context gives us access to a variety of different services within the Android infrastructure, within the Android API. And it's usually, the context is usually our entry point into other Android APIs. So activities are contexts, but so are the application objects. And the difference is that an activity object can do everything that an application object can do, but more, if that makes sense, even though they're both contexts. We'll see uses of when we use context. Like we use it to get resources, for example, load resources. We use it to get our layout inflator and all that fun stuff. And we'll see a lot of examples of when our context is needed and kind of get a more intuitive idea of when we would need one and when we would pass one through. Now, in the case of this auth class, at the moment, we're not going to be using the context, but in the future, we're going to be using it to store information. So what I want to do is for this auth class, I want it to have a reference to the application context. And that's why I'm creating the private final context so that I have that reference for later, so that I don't have to come back here and change code when I do need access to the context. I also want to show it as an example of another way we can generate code within Android Studio. And that is, so notice how I have private final context, which the final keyword simply means, again, that this field can only be set in the constructor. Notice how it's squiglified, and it's squiglified because it's final, but we haven't initialized it in the constructor yet, so it's all squiggly. And basically, the final will make it so that there will never be any other value in this variable other than what's set in the constructor. When you have a reference to a service, like a context, something that's not going to get a new reference, then always mark it as final. And that just that prevents silly mistakes down the road, basically. You're showing your intent that you want this to be not changed throughout the duration of the lifetime of this object. Now, where is the context going to come from? Well, I mentioned that a context, there are two kind of levels of context, activity and application. So we're actually going to pass in the application itself into the constructor of auth and set that as the context, because you can think of this as a service dependency. So how would we do that? Well, we would write a constructor that takes a context as a parameter and assigns it to that. Or we can hit Alt Insert. So basically I held down the Alt key and hit the Insert key and hit Enter on constructor. Then what I'm going to do is I'm going to select, using the up and down arrows on my keyboard, context. Now, if I wanted both of these selected, I can hold down the Shift key and press down. But in this case, the user is going to be instantiated by the auth class itself. The context is going to be passed in as a constructor parameter. So I'm going to select that and hit enter. And now we see that this code was automatically generated for us. This constructor that accepts a context and simply assigns it to its local variable. But we're not quite done with our implementation of auth. And that is because we need to instantiate our user object. So I'm going to go ahead and say user equals new user. So basically all this means is we now have a new instantiation of our user class, and we can now access it. Now we're going to need a getter for this. So our auth class owns a user, but now because there's currently no way to get a reference back to user. So what I'm going to do is, there's two ways to do this. I could do it manually, or I can come up here, put my keyboard cursor on the field, hit Alt-Enter, and say create getter for user. Now I don't want to create a setter for user, I only want to create a getter. So I'll select that and hit enter on my keyboard, and now we have our public user get user method all implemented for us. So yeah, that's basically our auth class so far. Now we will go ahead and we will later implement a logout method, but the reason we can't do that yet is we don't have the login activity yet. So we will have a logout method in our auth class, but not right now. Okay, so that's our auth class. So now what we can do is create our application class. So I'm going to right-click infrastructure, select new Java class, and in this case what I'm going to call it is Yora application. Now there's a reason why I'm not calling it an application. The reason is the class that this is going to extend is called application. Now, using fully qualified class names, you can make it so that will work, so both classes are named the same, and then you just qualify which class you mean every time you reference it. But I find that extremely obnoxious. So instead, what I'm going to do is I'm going to name this application class different from what the application class we're inheriting from is. So that application class that we're inheriting is going to obviously come from the Android namespace. I'll go ahead and get rid of that for now. So we're going to say extends. Now all I have to do is type in an application. The one that we want is located in the Android app package. So hit enter. And now we have our application. So this application is going to be pretty straightforward. There's not a whole lot of stuff to it. It's basically just going to be used as a bag for static services. Basically just a bag for singletons. A single point in which all of our singleton classes are described. We do this for code cleanliness purposes, deterministic initialization purposes, and, well, avoiding static as much as we can purposes. So again, remember, an application is a context. So what I'm going to do here is I'm going to give it a private auth, and for the auth, I'm going to, of course, select our Combuz Yura infrastructure auth. Then I'm going to say override public void on create auth equals new auth, and then of course or auth equals new auth this, of course, and then of course I'm going to say public auth get auth return auth. So basically, again, it's just a bag of singleton objects. Okay, so first thing that you might not, or you might be thinking about, if you're paying very close attention, you might be wondering why this is. Why don't we create our own constructor and make auth final? Why are we using the onCreate method? So you notice I could go ahead and do something like this. I could do that, and that would actually be arguably better design as far as code quality goes. However, the problem with this is our application object may not be fully initialized at this point, and we may not be ready to actually access some of the things that the application context will give us by the point that our application constructor is invoked. Because remember, the application constructor is going to be the first thing in this class that'll be invoked. Now, I don't want to... I want to make sure that the Android infrastructure is initialized as much as possible before I instantiate my auth class, because the auth class has a dependency on the application context, because we're going to be using it in the future to store information. So as a result, what I do instead of this is I override the onCreate method. Now the onCreate method is very similar to the activity onCreate method. The onCreate method of the application is going to be invoked before any activity is created. In fact, you can think of this method as the entry point to our application. Even though overriding this method isn't strictly required, you can think of it, like I said, the entry point of the application, where the code starts, the first piece of user code to be invoked, other than the your application constructor, of course, but that has as much as the Android infrastructure created as possible. This is created before even the first activity is launched, or instantiated even. And of course, I do want to go ahead and just follow convention by doing super on create at the top. Always invoke the base class, base type, or base method, even though, as you see, it's empty. Anyway. So, that is our application. Not too exciting. Again, just a bag of stuff. But right now, Android doesn't know about it. Android doesn't know to instantiate your application instead of a normal application. So we need to tell it about that. And we do it in the file that we tell Android about most things. And that is going to be our manifest. So jumping into the manifest folder and then selecting Android manifest.xml, you'll notice we have a fairly empty manifest. And that's because, of course, we didn't auto-create an activity when we generated this project. Now, the first thing I'm going to go ahead and do is I will go ahead and break these out onto their own lines because I find otherwise it to be very ugly. But anyway, so we have our application object with our different properties like our label, our icon, and our theme. We have no activities. How do we instruct Android to instantiate our application singleton object here when the application launches? Well, we do that by specifying the name attribute, which I find kind of... I'm not a big fan of that. That doesn't make any sense. Application name, like why can't it be application class or, you know, entry point or something like that? Name is kind of silly because it implies like how this application is going to show up in your launcher, which is label. I don't know. Poor choice of name in my opinion. But anyway, we're going to use the Android :name attribute, the name attribute in the Android namespace. And for the value, we're going to put in infrastructure.yourapplication. I could just hit enter, and that's because what happened was Android Studio went off, found every single class that could fit here, and found me the one that would. But in this case, I'm going to type it out because I want to show you guys something. So I'm going to type in .infrastructure .yourapplication. The reason I'm typing this out... come on. Did I misspell that? Oh. I am stupid. Let's just autocomplete it and talk about it and say... so used to C# with uppercase namespace names that I was sitting there and was like, why isn't it autocomplete? Why is it autocomplete? That's actually a complaint I have against the autocomplete in Android Studio. It is always going to be case sensitive. So if the thing you're looking for starts with an uppercase, it's not going to show up in the autocomplete window unless you start up with an uppercase. Kind of annoying thing. I'll leave this on video just because, I don't know, show you guys how frustrating it is sometimes to deal with different languages all the time. Okay, what we're looking at right now is .infrastructure.yourapplication. Now, technically this is supposed to be a fully qualified path to a class, and in this case you notice it's not. Notice how there's a dot followed by a incomplete package name followed by the name of the class inside that package. Whenever you see this inside of the Android manifest, whenever you see a reference to a class somewhere, such as the name of an activity, if the first thing is a dot, what that basically means is it's going to append that what you typed in to the package of the actual project. In this case, the package of the project is com.buzz.eura. So by doing .infrastructure.yourapplication, it becomes com.buzz.eura infrastructure your application. Now I could have done com.buzz.eura infrastructure your application as well. And if I had a different package name that wasn't the default package name of the class, then I would have to specify it absolutely. But we're going to keep specifying things relatively because it makes a lot more sense and is a lot cleaner. Anyway, that is our application element now. Now that we have this, we will now get a reference to an instantiation of our custom application class whenever we ask for the application. So that's really cool. But how do we go about actually asking for the application? Uh, well, there's on our activities, there's this method called getApplication, and that application or that getApplication method is going to return not our custom Euro application statically. It's going to return this because that's the return type of the method. Now, of course, we know that the actual object is an instantiation of our subclass, but of course, Android doesn't know that. So what we're going to do is we're going to write a base activity class that does this for us, that acquires this application object and performs the correct casting. I don't know if any of that came out very well. I hope it did. Okay, so what we're going to do is we are going to do a little song and dance with the project window. What I want to do is I want to create a new package. So what I'm going to do is I'm going to go ahead and right-click Infrastructure, or I'm going to go ahead and right-click Java. Let's see if I remember how to do this. Go to Package. We want to create a new package, and what we're going to do is we need to select the directory structure. So remember how we have the different flavors, different variants, and how they have different root Java folders? Well, in this case, we have our test project and our main project. So we want to select the main project and then hit OK. And then for the package name, we're going to type in com buzz Euro activities. And then we're going to hit OK. And now, as you see, we now basically have split that flat view of our package hierarchy into two packages, two leaf packages right here. We have our activities package and our infrastructure package. Okay, so now in our activities package, what we're going to do is we're going to create our base activity class. So I'm going to right-click activities, select new, Java class, and I'm going to call this base activity. Hit enter. The base activity, not surprisingly, is going to be marked as abstract because we are not going to ever directly instantiate it. Instead, we're going to intend that the subclasses, or that it's going to be subclassed, and those are going to be instantiated. And of course, we're going to have to make sure that we inherit from the proper activities class, the property activities subclass. Now, in the case of the way this project is set up, because we're using, as you see right here, the app compact library, which we'll talk about later, we have to make sure that we inherit from action bar activity. So I'm going to say base activity extends action bar activity. All right. Okay, so now let's go ahead and finish our base activity. We're going to be adding a whole lot more stuff to this class, but for now we're going to keep it straightforward. I'm going to have a protected Euro application. Again, notice how this is the first time user code required that we imported the new package. That's because the activities package is not in the infrastructure package, which of course is going to require that we import it. And then I was able to import it just by typing in your application, hitting enter. Now we need our onCreate method. So I'm going to say protected void onCreate bundle saved state. Of course, bundle brought in the import of Android OS bundle. The first thing we're going to do, as always, is invoke super onCreate. Then basically all I'm going to do for now is I'm going to say application equals cast to your application get application. So notice how the get application method of right here of an activity returns a base application class. Now, since we've overridden the application, we of course need to cast it to our overridden application so that we can get access to all the functionality that we're going to add to this application object. So that's basically our base activity class. It's not terribly interesting. Let's go ahead and move on and create our login activity. So our login activity, we're just going to stub it out, basically. We're going to stub it out here for a sec, then we're going to jump back, create another base activity, then our main activity, and then we will have all of this done. So you guys might be starting to see why I'm trying to shove all this stuff into one video, because there's going to be a lot of back and forth between these two, or between our variety of files that we have. Tried to make it as straightforward as possible, however. So in activities, I'm going to go ahead and right-click, select new Java class, and I'm going to call this the login activity. Hit enter. Now I'm going to extend the base activity. Okay, so what do I want to have inside of the login activity? Well, nothing quite yet. We're going to keep the login activity blank. We're going to come back to it once we have our main activity. There's this kind of a circular dependency we have going on with some of our classes, so I can't implement what I want in the login activity yet. I just need to make sure that I have the class there so our code will compile as we go. Okay, so now we have our login activity. I want to go ahead and make sure that before I forget, we go into the Android manifest, we find our application element, we add a new child element of activity, and we give it a name of login activity. So that was really quick, just a couple of keystrokes. It was open up tag, hit enter for activity, hit enter, select our login activity, hit enter, hit space, and then hit close tag, and then it auto-completes it like that. So a really quick way to put together our activity. Now, because we're not going to be putting anything inside of this activity element, we can go ahead and safely self-terminate it with that syntax. That should be familiar to anybody who's worked with XML or HTML. Okay, so now that we've done that, our login activity is now recognized by Android. What we can do is we can come back here to activities, and I'm going to create another base activity. Now, the purpose of this base activity should be fairly obvious. It's going to be called base authenticated activity. So the base authenticated activity is going to inherit from our base activity. Now, what's the purpose of a base oh, did I misspell that? Yes, I did. See, notice how it squigglified that word activity? I like spelling. Or I hate spelling. I like that it spells for me. Let's go ahead and go to refactor, rename, and rename this to activity. There we go. All right, so our base authenticated activity is going to be the base activity for the majority of the rest of our activities in the app. Why? Because it's going to enforce that we are logged in. If we are not logged in, it's going to either log us in with cached login information or shoot us all the way back into the login activity. So let's go ahead and implement it. Now I'm going to do something interesting with this class. So watch this. I'm going to say override protected final void on create bundle saved state. Then I'm going to say, wow. Then I'm going to say super on create saved state. Okay, so what am I doing here? Notice how I say protected final void. So there's that final keyword again. I think I mentioned this a couple videos back, but final is like, it has so many different meanings in Java depending on where you see it. I'm kind of a fan of the C# way of most every context has its own keyword. So for example, in C#, this would be protected sealed void on create. So what does that mean? Well, it simply means that subclasses cannot override this method. Now, why would I want that? I want that for the reason I discussed in a previous video. We are no longer going to override our onCreate method for the activities that inherit from base authenticated activity. And I'll go ahead and write the code out, and then I'll tell you guys why. So what we're going to do is I'm going to say if not application.getAuth.getUser.isLoggedIn, then that means we're not logged in. So notice how I say if not application. Application is, of course, the protected field that I got from my base activity. Remember my protected your application. GetAuth is going to get our auth singleton. GetUser is going to get our user DTO. And then isLoggedIn is the attribute on user that determines if we're logged in or not. Now, if we're not logged in, what are we going to do? Well, we're going to flesh this out later once we introduce our auth tokens. But for now, all we're going to do is if we're not logged in, we're going to shoot you back to the login activity. So no matter what activity gets launched, if you're not logged in, you get shot back to the login activity. So what I'm going to do here is I'm going to say start activity, new intent, and then for the context, I'm going to pass in this. For the login, the activities, I'm going to pass in login activity.class. Then I'm going to say finish and then return. All right, so that's the first part. Now, what's the second part? The second part is I'm going to invoke a method. I'm going to say on Yora create saved state, and then I'm going to implement this method as an abstract method. I'm going to say protected void on Yora create bundle saved state. Now, of course, well, what am I doing? I mean to say that it's protected abstract void. Of course, by saying protected abstract void, I need to make sure that the class itself is marked as abstract. So I kind of forgot to do that. So make sure you mark the class as abstract, just like right here, and then go ahead and implement your protected abstract void on your create, and then invoke it at the end of on create. So why are we doing this? The answer is basically the same thing as the answer of what we talked about in the last video. When we are not logged in, we're going to replace the current activity with the login activity, right? However, if we did this on the onCreate method and other activities inherited from this class and overrode the onCreate method, their onCreate method will still be invoked, which is just wasted cycles, because their onCreate method is going to do things like initialize the layout, find a bunch of views, set on click handlers, and all that fun stuff. This way, the onYoraCreate basically means that this method will only get invoked during onCreate if we are logged in. If we are not logged in, this method does not get invoked, meaning we can safely override or implement this method in our subclasses, and we are sure that that code will not run if we're not logged in. Another nice thing about this is we're able to make the onYoraCreate abstract, which will help us with code generation in the future when we implement or create subclasses, because we can automatically generate the stub for this method much easier. Because, of course, marking it as abstract forces any subclass to implement this method. Anyway, so that's our base authenticated activity. Let's go ahead and create our main activity. So on activities, I'm going to right click, select new, Java class, and I'm going to say main activity. Now, what's our main activity going to be? Well, our main activity is basically going to be the message list, the inbox list of all of our messages. So for the main activity, I want to ensure that we are logged in. So I'm going to say extends from base authenticated activity. Now notice how it goes red. Now we get a bunch of red squigglies. It squigglified our code. We got an error because we're not implementing the onYoraCreate method from the base authenticated activity. So how do we fix that? Well, we just hit Alt Enter, Enter, Enter. So Alt Enter, or Alt Enter, and then 2 more enters, and we have our onYoraCreate method. Now, what's this method going to do? Nothing for this video. We'll come back to it later. But for now, our main activity is effectively done because it's going to require that we're logged in. Let's go ahead and implement it in our manifest. So coming back into the Android manifest, I'm going to go ahead and make Android aware of our main activity. I guess just for convention's sake, I'll go ahead and put it at the top because it is going to be our launcher activity. So what I'm going to go ahead and do is say activity, and then I'm going to select main activity, and then I'm going to close the tag, but I'm not going to do a self-closing tag because we're going to, in order to mark this activity as the launcher activity, as the activity that's going to be launched when we open our application, we have to give it an intent filter. So the intent filter goes inside this element, and I'm going to say intent filter. Inside here, I'm going to say for our action, we are going to have a name of main. I hit enter, so it auto-completes the package name. And then for our category, we're going to have a name of launcher. And then have that autocomplete for us. So this will mark our activity as the thing to be launched when our application starts. So that's our main activity. Now that pretty much wraps up our manifest for what we want to do in this video. So I'll go ahead and close everything for now. The last thing that we need to do before we can go ahead and run this and see it behave in the way that we want is to go into the login activity and implement it somewhat. What I mean somewhat is I'm going to have a button, and that button, when it's clicked, is going to log ourselves in and then launch the main activity, just to show you guys that it's working properly. So what I'm going to do here is I'm going to say override public void or protected on create bundle save state, super on create save state. Okay, then I'm going to say set content view. Now what I'm going to do here is you might be saying, well, what are you doing? You're setting content view, but you haven't created a layout yet. Well, watch this magic trick. I'm going to type in R dot. Now notice how I typed in R, and then on the autocomplete, I selected Combas Eura for the R that I want, which of course will import it up there at the top. I'll say R dot layout dot activity login. Now notice how activity login is red. That's obviously because we don't actually have an activity login layout. But we can really quickly create one by hitting Alt-Enter and selecting Create Layout Resource File. So I'm going to hit Enter. Now we're going to get a dialog that says New Resource File with a bunch of options. For this case, this particular layout file is going to be used for every screen until we change that in the next video. So I'm not going to worry about qualifiers. For the root element, I'm going to change that to a relative layout, which of course I can get to by typing in REL and hitting enter for the root element. That's just so I don't have to go in and change the linear layout to the root or relative layout. Now that I have that done, I'm going to make sure that, well, I don't have to make sure, but the source set, of course, is main. Directory name is, of course, going to be layout. Then I'm going to hit OK. All right, so that's our layout. Jumping into the text view, I'm going to go ahead and make all of our attributes on their own lines. And then I am going to go ahead and let's go ahead and associate it with our login layout. So to associate with our login layout, we can, I can't remember what button it is. It's this button right here on the preview panel. It's associate with other layout or other activity. And then I'm going to select login activity. I always try to make sure that I associate it with the proper activities, the layouts with the proper activities, just because we get some additional benefits from the editor. However, for all intents and purposes, the fact that we've associated this layout with a login activity means nothing to Android. In fact, you'll notice that right here, the way in which it's associated is by using the tools context attribute. Notice how it comes from the tools namespace and not the Android namespace. Android doesn't care about the tools namespace and will effectively ignore it. The tools namespace is going to be used only by editors, such as IntelliJ or Android Studio. Notice how that when I associated the activity, the XML namespace tools, or the tools XML namespace was defined properly up there. Anyway, inside of the relative layout, I'm simply going to have a button with a layout width of match parent, layout height of wrap content, a text of login, and I'm going to go ahead and do an on-click of do login. So, yeah, so that's our login button. It's going to have an on-click of do login. Obviously, we're going to be removing this view in subsequent videos, but for now, we're just going to do that. Another nice thing about the fact that I set the tools, the context to the login activity is over here on click, notice how it's highlightified, right? What I can do here is I can hit Alt-Enter, not surprisingly. I mean, I'm seriously wondering why there isn't an Alt-Enter make entire app for me now button, but I guess they're working on it. Anyway, I can hit Alt-Enter and select the create do login method in login activity. Hit Enter, and now I have this method, and I'm back at the activity, so I can go ahead and write the implementation. As far as the implementation goes, it's going to be very straightforward. I'm going to type in application.getAuth get user set logged in true. Then I'm going to say start activity new intent this main activity class and finish. So all the do login method does is it forces our auth class to assume that we're logged in, starts the main activity, and finishes. So basically, if everything is working properly when we launch this, what should happen is we should have a login screen. We should be able to hit the login button. Then we should be redirected to the main screen, which should be empty because, of course, our main activity, we don't set any content views. So let's go ahead and do that. I'm going to hit run. Should only take a second to build here because there's so little code. That's going to change over the course of the next forever videos. And then I'm going to select my Genymotion device. And I checked the use always. All right, so we have success here, or at least a partial success. Notice how we are now seeing our login view, which is cool because our main activity was supposed to be the startup activity, but because we're not logged in yet, we get the login view. Let's hit login, and we get a new blank activity, which is the main activity. Okay, so yeah, I hope you guys enjoyed that video. Basically, all we did was we set up sort of a skeleton of our project. We set up some points in which we were going to come back to later to flesh out more, but I just needed to get this bare minimum amount of classes out of the way. So what did we do again? Well, the biggest thing that we did was we created our own application object. So we created our own class that extends from application. It's nothing more than a bag of static objects. However, I prefer doing this over singletons because we can control the order in which our singleton services are instantiated. It also makes things much more conducive towards testing because we're not relying on static variables. Anyway, the only global service that we're providing with our application class is our auth service, which is simply right now a container for our user DTO. And our user DTO is simply a container for a variety of properties that we haven't yet taken advantage of yet. After we did that, we went into our base activity, created the base activity that all activities in our project are going to inherit from. At the moment, all it does is properly sets the application field by casting the result of the getApplication method. Next, we made our base authenticated activity, which is the base class for most of our activities, because what it's going to do is it's going to force us to be logged in order to get into that activity without having to add any more additional code in any of the other activities. Our login activity, which note it's a base activity, not a base authenticated activity, because otherwise we would have an infinite loop of activity starting. All it does is it forces us to be logged in and starts our main activity. And our main activity does nothing. Well, technically it does do something because of the functionality inherited from base authenticated activity, but on the create method you see it's empty. And that's really it. Other than that, all we did was mess around with our manifest. So that sets up the skeleton of our application. I think we have enough code to start actually working with source control. So in the next video, we're going to go ahead and get that set up. And we'll see you guys.